Okay, so we are still working with 9.5, which is mean absolute deviation. We are on example 2. So it says the smartphone shows the numbers of runs allowed by a pitcher in his last 10 starts. Find the mean, median, and mean absolute deviation of the data. So we're not only just finding the mean absolute deviation, we're finding the mean, which we'll be finding the mean anyway, and then we're finding the median. So no matter what, for median, we have to order the data. So we might as well just order it. All right, so we're going to order the data first. So we have, and here's all your data sets right here. So we have 0, I think we have 3 zeros. And then we have a 2, a 4, a 4, a 5, a 6, and an 8. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It says we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, so we're going to find the median, which means if there's 10 data, so we're going to have an even number, which means the 2 middle values are going to be helping us find the median. So cross off. And then these 2 are to help you find the median. Now, they're both the same, so technically your median's 4. But what you really do is you do 4 plus 4, and then divide by 2. 8 divided by 2 is 4. So that's your median. Okay? That's your median. All right, now let's find the mean. So to find the mean, it's going to be 0 plus 0 plus 0 plus 2 plus 4 plus 4 plus 5 plus 6 plus 6 plus 8. We should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to divide by 10. So it comes to 35 divided by 10, which is 3.5. So our mean is actually in the middle. So it's right here is our mean, which is 3.5. Okay, now we have to do our dot plot. So let's put our dots where they should be. So we have 3 zeros. We have a 2. We have 2 4s. We have a 5. We have a 6 and a 6, and we have an 8. I really would like you to put all this on graph paper and practice. If you don't use graph paper for this, please make sure it's on the printed out notes, okay? All right, so now we have to do our distances from the mean. And this gets tricky because this is 3.5. So we have a dot on 2. So it's really negative 1.5 distance away from the mean, okay? And then the zeros are negative 3.5 distance away. Okay, and then our 4 is 0.5 away from the mean, and then our 5 is 1.5 away, and our 6 is 2.5, and then our 8 is 4.5. I wish I knew how to make them thinner. I don't know how to do this thing. I'm so upset. Okay, so we do need to do the absolute values of these. So this is where it's going to get a little crazy over here because the pen's so thick. All right. And now you're going to go over to your new number line and rewrite them as the absolute values. Okay, so you should have all positive numbers. And then remember, this is the mean, which is 3.5. Okay, so at the 4 we have 2. So it's 0.5, 0.5. 5 we have 1.5. 6 we have 2.5. 5. We have 2 of them. And then at 8, we have 4.5. Okay. So now we have to find the mean of all of our absolute values. So you're going to do 3.5 plus 3.5 plus 3.5 plus 1.5 plus 1/2 plus 1/2. I'm going to go over to the side here. Plus 1.5 plus 2.5 plus 2.5 plus 4.5. And we're going to divide all of that by 10. All right. And then you get 24 over 10, which is 2 4/10. And this is your math. So when you go down to your graph, you're going to go 2.4 over. So you're going to go, so 4.5 is 1, 5.5 is 1. So it's a little bit like right here. Okay. And then it's same here. So let's go. This is 1. This is 2. So it's like right here. So our mean absolute deviation, right? It varies it varies 3.5 on both sides. I'm sorry, 2 4/10 to both sides of your mean. All right. So when you're looking at it, it looks pretty good because this is where your cluster is right here. And that kind of makes sense. All right. Everything on the 0 and the 8 are your kind of your outliers, like extends far out. All right. Your cluster is where it is. All right. Great job on finding mean absolute deviation. I hope this helped. You can rewind and replay as much as you want. Bye, guys.